Good day and welcome to yet another presentation in the series of presentations for Oracle Virtual Developer Day. My name is Czuprynski and I'm going to be guiding you through a presentation on Oracle Database 12c Release 1's newest feature, Automatic Data Optimization, sometimes called ADO. And as I titled my presentation, data is hot, 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 isn't it? It certainly is. When we talk about big data today, we talk about the volume of data that's being produced and the speed at which data is being produced. We need to get our heads and hands and databases around that data. And so that's what ADO is actually going to focus on. Now, let me tell you a little bit about myself. I've been in information technology for over 30 years. I officially became an Oracle DBA in 2001. Since that time, I have achieved my 9i, 10G, and 11G Oracle Certified Professional designation. I'm working on my 12c professional designation right now. When I'm not mentoring, consulting, talking with other DBAs, I'm also writing. I spend a lot of time writing articles for publications like IOUG Select Journal. My name may sound familiar to you because I just had an article on 12c security features published in the last quarter's journal. Also, I've got around 100 articles on databasejournal.com, and recently I started writing for Confio Logical Read. When I'm not writing or working as a DBA, I'm teaching. I spend a lot of my time teaching Oracle DBA core curricula for grid infrastructure and real application clusters, Exadata, Oracle database performance tuning, data guard features, and of course, even Golden Gate. I'm a regular speaker at Oracle Open World. I was at Collaborate 13 last year and OUG Norway in 2013. I'm going to be returning to both of those venues this year. And I also found out recently that I've been accepted as a speaker at Hot Sauce 2014. I'm thrilled to be attending. It's a very short list of folks that are usually allowed to give presentations, and it's a great honor to have that opportunity. And when I'm not doing any of that, I'm posting some information on my blog. I'll have the link to that a little bit later in the presentation. If you've taken classes with me, you probably remember me responding to one of your questions, at least one of them, with the phrase, generally, it depends. And hoo boy, if that isn't true these days, because the complexity of everything Oracle, Exadata, Exalytics, Exalogic, different storage technologies, ever-growing databases, applications and hardware being integrated together on enterprise platforms like Exadata, our world has gotten incredibly much more complex since I became an Oracle DBA. Before we get to any of the presentation material, however, I do want to mention our standard Oracle disclaimer. Yes, this is interesting material I'll be presenting. However, I cannot guarantee that it's going to work exactly the way I'm presenting it here today, and please do understand that some of the features I'm mentioning here may or may not be available in your environment. For example, if you're working on 11G databases, obviously none of these features will work. However, if you're working on Oracle 12c and working on Exadata, and if you've recently patched to the most recent version of Exadata, you probably have even more power at your fingertips. So as Steve Jobs might say, let's get started. Here's our agenda. First off, automatic data optimization. Why bother? It's a lot of work. Well, not exactly, but it's not trivial to set up. Why bother? I really believe that the secret to being an effective Oracle database administrator or an Exadata database machine administrator, a DBMA, is to be able to understand the why of what you're doing. The what, the when, the where, the how, that's in the documentation. But understanding why it works the way it does, that's what I'm big on. And that's what I'm going to try to get to you today. Also, ADO has two different mechanisms. We can do space-based ADO as well as time time-based ADO, and I'm going to show you some examples of both. The whole point of automatic data optimization is when it makes sense, compress. And we're going to talk about leveraging that concept throughout space and time-based ADO policies. We'll look briefly at a concept called heat maps. Heat maps are brand new in Oracle 12c Release 1, and we can see at the table space segment and, are you sitting down, row level, really at the database block level in which the row exists, but we can get very, very deeply into exactly how data is being touched, manipulated, and used, or more importantly, not used. I'm going to put together several examples of ADO policies, showing you how it all works, the results of those policies, and at the end of all this, we'll have time for Q&A. So why bother implementing ADO? Well, there are several things going on in our industry that it's pretty obvious if you've been watching what's been going on. First off, flash storage, solid state devices, even devices right on the PCIe bus are getting larger, more reliable, and cheaper as the day goes by. And disk storage has never been cheaper. Now, your storage administrator might want to argue that one with you, but trust me, go over to your local hardware store, if you will, not Ace Hardware or anything like that, but go to your local Best Buy or whatever your electronics store nearby you is and ask how much a 2 or 4 terabyte drive is. And when you do the computation, you'll realize that a gigabyte is now less than a nickel. Now, that doesn't always apply to, obviously, non-commodity drives, what we might call enterprise drives, but it's still gosh darn cheap. Another thing that's changed, CPU resources are immense at this point in time. For example, the newest version of the X4-2 Exadata database machine has 192 cores. CPU used to be one of the limiting factors in database performance. Not anymore. It's so cheap and so available, it's not even a limiting factor. So what we'll concentrate here is getting advantages from compressing data. The biggest challenge is still getting data from disk, not solid state, but from disk in a reasonably quick time, and avoiding physical I/O as often as possible. So we'll talk about using compression to make a difference there. One of the big things about compression that I've figured out over time, and if you're an experienced Oracle DBA, and by the way, experience is the most painful teacher, it is not the best teacher. Proper compression usage takes a lot of forethought. For example, flash-based storage is a great target for random access, especially online transaction processing or OLTP, but it's still somewhat precious. It's cheaper, it's ubiquitous, but it's not free, and it still is much more expensive than hard disk drives. Also, just because we can do something doesn't mean we should. And just because we can compress data doesn't mean we're necessarily going to get any benefit from it. In fact, we could see negative performance of an application by using the improper level of compression. On the other hand, if we've got data that's literally ancient and no one ever touches it and really doesn't plan to touch it anymore, or hardly ever touches it, or only uses it in read mode, perhaps sequential read, perhaps as part of a table scan, we could get immense performance benefits from compression. So how does this ADO thing work? Well, it either moves or compresses data based on how the data has been used. And what do I mean by used? Well, we'll talk about that in just a matter of seconds. The first thing to understand is that ADO uses heat maps. And we're going to see an example of heat maps here in a few more slides. But the idea of a heat map is, where is the data hot and where isn't it hot? Because if data is truly hot, being accessed with random access DML, for example, or being accessed in a random access fashion for read. It doesn't necessarily make sense to compress it. So we want to know where the hot data is, and more importantly, where isn't the hot data? Where is the cold data? Because a lot of can bias excellent opportunities for compression. Heat maps through ADO track exactly how data has been utilized. What do I mean by that? Well, I can tell you whether or not a particular segment, a particular table space, heck, even a particular database block is being used primarily by a query or primarily by DML. And I can tell you if it's being used for small reads and writes versus a full table scan. And we can track these usage patterns at the highest level, table space, segment level, and even at the row level. That's an incredible amount of power. And we're going to use that to our advantage to implement ADO policies. As I mentioned earlier, by the way, we can cover the space-time continuum. Albert Einstein would be so proud of us. Yes, it can be based on either space or time. Remember what Albert Einstein liked to say. The definition of insanity is doing the same thing over and over again and expecting different results. And if you've been trying to implement some sort of compression methodology to save space inside your databases, maybe it's time to look at something like ADO, because we can avoid the insanity. A space-based policy will move data between table spaces in different storage tiers. And it's based on how full the initial table space has become. So where would we probably use this? More likely than not, flash-based devices. For example, on Exadata, if we had a flash-based grid disk, it would probably make excellent sense to leverage space-based ADO. But we also have the ability to do time-based ADO. We can compress data more tightly within the same segment if we want to. We also have the ability to compress really at 3 levels of grouping, if you will. One is group, the last one in the list, and I'm not going to spend much time on this because it would give us the ability to have a much longer discussion, but we have the ability to group several database objects together and compress them based on some type of activity. But most of the time, we're going to be using either row storage or segment ADO policies. Row storage, as you might guess, has to do with how hot, how busy a particular row within a particular database block within a segment, how busy that is, and how it's being accessed. And segment level is a little bit different because we're going to look at the segment as a whole. And the frequency at which we will evaluate these two policies is also quite different. And we'll show you an example of row versus segment ADO policies coming up in a few more slides. So let's take a look at a space-based ADO migration policy. So here I've got a table space living out on some flash device, a solid-state device. It could be a Fusion I/O card that's inside a compute node's PCIe slot, one of the fastest ways to leverage solid-state devices. Basically what Exadata does, except we use F40s or F80s as our what we call FDOMs, flash disk on memory. We also, as it could be using a solid-state device, something inside a SAN. There's nothing to stop us from doing that. There are pluses and minuses to all these approaches, especially if you don't have an Exadata. You're kind of going to be limited to using either the first or the third method. But if you have Exadata, this is already built in as soon as you build a flash-based grid disk. So we've got a segment here sitting in plus flash, and over time we add more data into it, you know, kind of like an OLTP data segment. Perhaps it's part of a partitioned table. Perhaps it's building because it's the next quarter's worth of data that we're going to eventually transition via partition roll-on into a partition table. But over time, that tier 0 storage, as we like to call solid state, I've heard sometimes called tier 1, but tier 0 is kind of an interesting, intriguing label for that. A lot of storage administrators call it that. That when we detect that the table space in use exceeds 90%, or the free space in the table space drops below 25%, whichever one is qualified, ILM, Information Lifecycle Management packages, procedures will detect this and will automatically, my friends, move that segment to a totally different table space. I have an example of exactly this for you to take a look at. By the way, all the code that I'm going to lay out here is not 100% complete in this presentation, but I'm going to be posting it to either the OTN site or my blog site a little bit later this week. You'll get a chance to see it. So in this case, a space-based migration policy is going to move one segment from one table space, its initial table space, to another. It's based not on time, but on space. Next, let's take a look at a time-based, not a space-based, but a time-based compression policy based on ADO. So here we've got 16 database blocks inside a segment, or they could be 16 extents inside a single segment as well. However we want to look at them, that's fine. The point here is that right now, this poor segment is being beaten on like a cheap tambourine. There is constant access by queries. Think of something like your sales information for your company, or orders, or invoices, or something along those lines. We are constantly going in, adding new invoices, altering the number of line items for each invoice, maybe deleting a line item from an order. And we're constantly hitting it with both DML and, of course, querying against it. Think Amazon.com, for example. People are constantly going in, looking at things, their current state of their order, but they're also possibly adjusting their order state, the order count, perhaps, other things that they're ordering, maybe canceling part of an order. Does it make any sense to apply compression against this segment? No, it makes no sense at all, because the compression will actually slow down the performance of this particular segment. But over time, maybe over 3 days, this particular segment, this could be a partition, could be, right, depending on how it's partitioned. I have worked at some clients where they've considered data old after 24 hours and ancient after 30 days because they were loading billions of rows into tables. In this case, after 3 days, what sense does it make to not compress, especially with something now in 12c that we call advanced compression, which gives us about a 4-to-1 compression ratio. Again, your mileage may vary. It's going to depend on the type of data, the row size, all kinds of factors come into play here. But I can save some space. Remember, advanced compression is separately licensable. You do need to license it separately to get its advantage. However, the main thing to understand about this is that I can now save crucial space, maybe on a solid state device, maybe on some fast disk that might be able to leverage advanced compression. Time passes. 30 days since we initially added the data, it's not being modified at all. We're still querying it every once in a while, but not that often. So let's enable a higher degree of compression. Let's use hybrid columnar compression, query low compression state, what we also call warehouse compression, low warehouse compression. And after 90 days, hey, this thing is ice cold. It's like winter in the Midwest this year. It's been a cold winter here in Illinois, where I'm speaking from. For example, in this case, we might apply archival high compression. I know, that's an Exadata thing. Well, not exactly. If you've got a ZFS storage appliance or you've got Pillar Axiom storage, remember, you can implement hybrid columnar compression as well. If you don't have that storage underneath your database environment, well, sorry, no, you wouldn't be able to leverage this. But the key thing to understand is that there are other mechanisms that we could use to even increase the compression ratio above advanced or even basic compression. Let's not forget we get basic compression, direct path loading compression, if you will, for free as part of enterprise. And that's generally about 10-to-1 compression. Remember that hybrid columnar compression, though, is a totally different type of compression using compression units and is designed for faster queries, not for DML access. So the idea here is we're going to use the right compression at the right time for the right job. That's coming up in a few minutes. So let me present to you an interesting, simple example. Let's assume that I have a data source that has about 3 million rows in a very small, very narrow 4-column fact table. And I've got about 10 years worth of history, pretty much evenly divided across all 10 years. I did this with a very simple insert statement into a table using DBMS random to get a nice even distribution. I want to load the data from that fact table into 2 different tables. One called AP, accounts payable, roll-on_parted, that's going to hold the last 3 months worth of data and any new data that might come along. Also, I'm going to have another table called randomized_parted, and that one's going to have all of my historical data storage. Eventually what will happen is AP.rollOnParted will become part of AP randomized parted by taking data out of that table and loading it into AP randomized parted. And notice the distribution. I've got a hot, a lukewarm, a cool, and a cold partitioning strategy. And I'll show you the coding in a few more slides so you can get a more DBA perspective on it, if you will. Hot data, anything from December 2013 and forward. The lukewarm data, as you can see, spans most of 2012 and a good part of 2013. The cool partition has 3 full years of data, 2009 through 2011, and anything before 2009, and there's a good chunk of this table that is containing data before 2009, is the cold partition. And here are my 2 goals for ADO. I want to make sure that the ADO hot data table space, you'll see where that's allocated in just a moment, on flash storage doesn't get overused. That screams a space-based ADO policy, doesn't it? And as time progresses and the data inside other tables, like my partition table, heavily partitioned table, gets colder, I'd like to go ahead and compress the data more and more as it gets colder and colder. So that's what we're going to look at next. The first thing I'm going to have to do, I'm going to have to talk to my storage administrator a little bit. Sorry, maybe my DBA as well, but we're going to have to work together on this. I'm going to have to build some sort of storage tiering. Now again, I'm using ASM terminology here. I have 4 different ASM disk groups, plus flash, plus warm, plus cool, and plus cold. And this is an example of actually how I set this up in my sample environment here in my home office. I've got a 30 gigabyte solid state device. Nothing too fancy. I bought it a few years ago. I used it for one of my laptops, took it out, made it as part of a flash-based grid disk, if you will, as an ASM, part of an ASM disk group. I've also got 2 other disks, if you will, fast and slow HDD. Well, to be honest, what it really is, it's the same disk drive, but I'm using the outermost cylinders for the faster hard disk drive and the innermost for the slower hard disk drive. You mean like in a normal Oracle database environment, could this be plus data and plus FRA? Well, you might be able to use them that way, but I actually built my own ASM disk groups to break this out separately. And then finally, plus cold is on the slowest disk that I could find laying around my home office. It is unbelievably slow, well below 25 or 30 milliseconds per single block read. But the point is, I don't need it to be very fast. I can leverage older storage because I'm going to store my oldest but still necessary data that's before 2009 on that particular ASM disk group. Now that I've got my storage tiers built, it's time to actually turn on heat mapping. And please pay attention because it's really difficult. Are you ready? Here's the steps. Alter system, set heat map equals on. That's it. This turns on heat mapping across the entire database. All objects inside the database can now take advantage of heat mapping. I'm not going to spend an inordinate amount of time on this, but I wanted to show you that once that's activated, I can start to see things like which table spaces have been touched for writes, which table spaces have been touched as part of a full table scan, and which table spaces have been accessed as part of an indexed lookup. So again, the first column here on the left, earliest write time, would indicate that we've done some sort of DML against data in the ADO hot data and ADO hot IDX table spaces. I've also done some table scans against the data there, but then finally I did some other access via simple block access. In other words, searching from an indexed value, maybe a range scan, maybe a primary key index scan to find a unique value. That's what the earliest lookup time column actually describes. That's at the table space level. And by the way, I'm just going to show you two views. There are several, almost 8, depending on how you want to count them. Here's an example of looking at heat maps at the segment level. Take a look at this, folks. This is showing exactly which segments have been touched in exactly the same way, via single block access, via full table scan, or via DML. In other words, that at least one block in one extent inside these particular segments has been modified. We have quite a bit of detail here, and you, by the way, if you know exactly how to use DBMS heat map and know how to access the objects in there, you can get down to the block level within each relative file number within each segment that's stored inside a tablespace's data file. That's pretty impressive. So my storage tiering is ready to go. I've activated heat map. What's next? Here's where things get interesting. I'm going to create my two tables, ap.rollon_parted and randomized_parted. Let's take a look at the non-partition object first. Notice this is going to be stored on ADO hot data, that particular table space. And this is what I would like to call an inline policy, an inline ADO policy. As I'm creating the object, I'm actually turning on an ADO policy. It's ready to rock at this point. What are we saying? That when this object and other objects inside the ADO hot data tablespace have consumed up to, as you'll see, 90% of the data inside that tablespace, I want to immediately move a segment or segments, whatever I need to move from ADO hot data to ADO warm data, so that that threshold is honored. I'm going to show you exactly how this works with my test cases. Let's take a look on the right side. We've got a partition table here, and again, these are the time ranges that we laid out several slides back, but take a look that I've got a cold, a cool, a warm, and a hot table space. And they correspond to, of course, the oldest to the somewhat more recent to the relatively recent to the right now data. Values less than max value says this is data that's after December 1st, 2013, and any other data after that. Notice, by the way, that right now, for that particular partition, P1 hot, I'm using no compression. Why have I got that specified in there? Because it makes no sense. I'm going to be hitting that particular partition. I'm going to be banging on that partition like a cheap drum all the time with DML and also very, very small queries. It makes no sense to compress that data. But it might make sense to compress warm, cool, and cold data. And that's what we're going to look at right now. Here's an example of setting up policies that are time-based. Now again, notice these are against the randomized parted table. And I'm using two different methods, by the way, of compression. The first one for P1 hot is a row store compression. And I'm going to use advanced compression against this, but only after 180 days have elapsed of no modification. What do we mean by that? After 180 days that no DML has touched this particular partition, I would like to compress the blocks within this segment, the ones that have not been modified after 180 days. The other three policies, you'll note, are using simple basic compression. That's what compress means in 12c. If this were an Exadata environment, I could be utilizing also hybrid columnar compression, either warehouse or archive high or low compression, as it might make sense. But these three partitions, P2, 3, and 4, notice are leveraging simple compression. And what are our time frames? 300 days, 600 days, 900 days of no data being touched inside these particular partitions. That's what is different, as you can see, from space-based ADO. My policies are in place, my heat maps are ready to go, but wait a minute, how am I going to test this? How am I going to test 180 days of no modification? Well, that's an excellent question. Let me answer it for you. There are several global policy attributes. These are just 4 of them that let me make very short work of testing ADO policies. The ones I'd like to bring your attention to are the 2 top ones. Second from the top, execution interval says, here's how often, dear Oracle 12c, really dear Information Lifecycle Management utility, I would like you to check to see for row level compression. Remember, our very first partition was P1_hot, and I used row storage, not segment storage. This is saying here, please check every 3 minutes. But even cooler is the very first one in the list. ILM policy in seconds. The default for that setting, actually the attribute called policy_time, is ILM policy in days. In other words, if I see days there or any subset of days, months, years, treat them like days, but not in this case. So 180 days would be treated as 180 seconds. 300, 600, 900 days get treated as 5 minutes, 10 minutes, and 15 minutes. So testing whether or not this policy really works and what's the impact and how much time it takes for the compression to actually happen, I've got this excellent ability to leverage these global policy attributes to actually pretend as if this policy was in place. Would I use this in production? No, but certainly on a test platform, it's an excellent way, and of course even in a development platform, to make sure that the policies are working as expected. The last 2 points here are on TBS % used and % free. These are the 2 values that determine space-based compression. So in other words, when I see that 90% of a particular table space that has a space-based ADO policy in effect against it, once it reaches 90% full, I will immediately initialize compression during the next ILM policy evaluation period. So that's how you can leverage these policy attributes. And as I said, I think there are about 8 or 9 of them right now, at least in the current release. Definitely take a look at them to make life easier for yourself as you're doing your testing. And of course, don't forget to set ILM policy in seconds back to ILM policy in days when it's time to actually implement it in production. All my pieces are in place. It's time to test. So let's take a look at testing a space-based policy. Remember that the AP roll-on parted table has a policy that says, hey, when I get to 90% full on its corresponding table space, stop what you're doing, and I would like you, dear Oracle 12c ILM, I would like you to move data from that table space, move that from that table space to hot to warm. And what I'm going to do here is actually execute a little script that's going to go in and add 50,000 rows at a time. Right around the 400,000th row added, I cross over into the 90% boundary of space used, and I'll show you the end result of that space-based policy firing off. So just a cool little trick here on adding test data into the system. Very simple, very elegant, works very nicely as a anonymous PL SQL block. How about testing other access policies, time-based policies? Well, here's a very simple way of doing it. I'm going to go ahead and look at, remember our partition that we had in the AP randomized parted table? The very first partition, data after 2013, December 1st. What I'm going to do in here is just update as no more than 50,000 rows that have a specific date range. Similarly, to play with touching particular partitions in AP randomized parted, I'm going to touch the warmer and the colder partitions with a simple query that's going to induce a table scan, actually a partition scan of those two different partitions, because these data are within those partition ranges. So that's my test case. That's really all that I need to set up for the different partitions. Of course, if space allowed, I'd also have one for the coldest table partition, but you get the idea from these 4 different examples. My test policies are all in place. My test code has been executed. It's time to actually get ILM to interpret the policies. Now, to do that, I have to do a little bit of extra work. I have to call DBMS ILM, that new package in 12c, and call the execute ILM procedure. By the way, I'm showing you a simple example of this, implementing it against roll-on parted and randomized parted, but you can, with execute ILM, actually drive down to the individual partition in a partition table. I'm keeping this simple for space purposes, but you can see after I've executed this over a period of time that finally, on the very bottom of the page, the roll-on parted policy was inaugurated. Notice the job number there in the very bottom right-hand corner, ILM job 562. This is ILM, Information Lifecycle Manager, saying, aha, I see that there is a reason to implement a policy. I will go ahead and make the policy come true. In other words, I'm going to implement space-based ADO on roll-on parted. Notice that above it, at the very top of this report, the other 4 partitions that are part of randomized parted, P1 through P4, were also selected after some time. Remember, those are time-based. So what would have to happen? When would they actually eventually all be executed? Well, after 180 seconds, 300, 600, and 900 seconds have elapsed. If I played with this and essentially implemented executing the ILM procedure above there at the right interval, I would see ILM say, okay, the hot partition, P1 hot, yes, it's ready to go ahead and have ADO do its magic again, but I'm not cool, not cool. If I waited a little bit more time, it would finally do that for warm and for cool. And finally, after about 15 minutes have elapsed, the final job against the P4 cold partition would be fired off. By the way, this job name is the job that gets run by DBMS Scheduler. Nothing magic here, folks. We're using the same tools that we've always had to execute tasks in background without any intervention by any DBA. The only thing that I'm really intervening here is forcing, if you will, the ILM evaluation before it's time. Normally, the ILM evaluation happens once every day during the maintenance window. except for row-based storage, in which case it will happen on a regular basis based on that one time parameter that was the second one on the list that I had showed you. So the ILM policies have fired off. Let's take a look at the results. Take a look at this. When I first started, the ADO hot data table space, which I sized prohibitively small at 25 megabytes. Remember, my assumption is this is on flash storage. I shouldn't need that much out there in flash storage necessarily to get good performance benefits. It's about 50% empty or 50% full. Depends on how you want to look at the glass. As I start to grow this table space, as I start to grow data and grow the segment that exists inside ADO hot data, however, at some point, only 1 megabyte of space is left. About 4% of that space is left. I've crossed both the 90% used space limit and the 25% free space limit. Well, what happens? As a result of that ADO policy firing off, that space-based policy, with me doing nothing else, automatically the segment has now been moved from ADO hot data to ADO warm data, and it's reflected automatically inside the two different table spaces space allocations. Do you see that? That segment has now been moved from ADO hot data over to ADO warm data, and as a result, the free space has now gone up significantly in ADO hot data. So that's a space-based ADO policy actually being implemented right in front of your eyes. So now let's take a look at the result of an ADO time-based policy being applied. Well, let's take a look at the 4 partitions that are part of APO randomized parted. Notice that at the very beginning, before any ADO policy ever fired off, here are the counts of the number of blocks and the average row length for each of the 4 partitions. After the ADO time-based policy went into effect, over time, let's take a look at the results. After a few minutes after I've applied the workloads, notice that now the compression level for all 3 of the warm, cool, and cold partitions have been enabled, and basic compression, not advanced compression, but basic compression, which gives me about a 10-to-1 compression ratio, not trivial, has been implemented. And note, there's been a measurable, not super significant, but a measurable decrease in the number of blocks now making up these particular table partitions. And so what? You might be asking. This seems like to be an enormous amount of work to do just to save some space. My storage administrator is just fine. He has plenty of space for me. Well, here's why. Here's what it really comes down to. Performance. Here's a few queries that I actually built right after I turned on and waited for those time-based ADO policies to come into effect. Notice that the before and after is measurably better after the compression has occurred. Now, this is for the warm segment, the warm partition. This is for the cooler partition. And this result is for the coldest partition. Now, the coldest partition, if you take a look at that in terms of just the optimizer cost, that's about a 16% performance improvement. And across the board, the performance improvement is somewhere between 10 to 15%. No code changed. Nothing else really needed to change except the implementation of a compression policy. So again, this is using just simple, what we call basic compression in 12c. Imagine what I could have been able to show you had my 8th rack Exadata database machine arrived here in my home office on time. I'm kidding. I don't have an 8th rack. I don't have access to that. But imagine what this would have looked like for Exadata. And I have tested it on Exadata. I was trying to keep this example simple so that it will apply for everyone. But against a quarter rack Exadata, simulated or not, it's quite an impressive compression ratio that you can actually get out. Remember, it's going to depend on the data that you've got inside Exadata and the data types, the number of nulls, the number of rows, the width of the rows. When we are talking about what hybrid columnar compression can do for you, those are all factors. But all things being equal, you could see significant positive performance impacts from leveraging an ADO compression strategy. That's all I have for you today. It's over to you and time for your questions.